Welcome to another RDWorks Learning Lab. Today I'm going to tackle a little problem that people have raised about the Mk4 laser pointer. Firstly, they don't want to fix it onto their water jacket because the water jacket is only fixed on with epoxy resin, and there have been experiences of the water jackets coming off. So that was reservation number one. Reservation number two was that it was too big, too long, and there wasn't enough space between the end of the tube and the first mirror. And the third thing is, for those people with glass water jackets where the surface of the water jacket might not be square, it might not be level, there's nowhere sensible to fix it onto. I've looked at all these possibilities and I've gone back and done a redesign. Here's the little animal that we're going to try and make. Now this is the Mk1 version, which I've modified for the purpose of this video. I've managed to use the little head out of one of these laser keyring pointers. It's supplied by Maplin in this country, UK, but I'm sure you'll be able to get something similar, provided it's only got a single laser and is not one of these multiple LED and laser pointers. I'm sure the laser head inside will be very similar. When we take this apart, we shall find that there's a laser head with a circuit board attached to it, which makes it quite long. So what I've done, I've separated the laser head, I've put the little circuit board, I've buried it down in here and linked it together with a little cable. Now the purpose of this now is that you've got on the bottom there a magnet which allows you to stick it into your enclosure and then adjust this section here up, and you can move this around so that it lines up with your laser tube, and then it's magnetically attached to the framework, and then it allows you to adjust these screws here. On this prototype version I've even got a little acrylic spanner that enables you to adjust these here, which allows the whole thing, if you watch it, the whole of the head floats and pivots. Sadly, I've had to go for a 3-pivot system because a 4-pivot system doesn't work very well. So basically we've got a fixed point there and 2 adjustable points here. Now the problem with this unit is that, as I found out when I broke the first one apart, there's a break line here, but it's glued in. Now the quick and sensible way to get the glue out of here, or to soften the glue, is to actually heat it up. I don't think we're going to be dealing with any problems here under warranty, so I'll start taking it apart. We'll take the keyring part off, and then we'll hold this in a vise. And then we're going to have a go at this with our paint gun. We're going to heat it up. And there we go. It's as simple as that. Now we've got it out of there, but now we've got to get the cap off. I don't want to clamp that bit too tight. Oh no, there we go, look, that comes off. As simple as that. That just literally pulls off. And basically we've paid £10 for that little module there. Now there are 2 or 3 problems that we should need to look at when we're dealing with this little module. The first thing is, you'll notice on this side we've got 2 terminals, and on the other side, which is the button side, we've only got 1 terminal. The way that the batteries go in here, the batteries touch on there, which is the negative side of the battery. So the positive side of the battery in fact goes to this termination here, which if you look at it closely you'll see is attached to the body of the unit. But you don't want to put anything on the body because that's a nice uniform body. So what we've got to do is make sure that we put the positive connection onto here and the negative connection onto here. The sensible thing to do is to make sure that we draw a picture of what this unit looks like. Now we need to know what these pins are because we've got to reconnect those pins with wires to their terminals when we take them off. With a bit of luck like I should be able to just gently tease these off a little bit at a time. Tee them both up together, and there we go, we've got them off. Right, I've just tinned the ends of those wires. Now, this is a bit like heart surgery. We're going to have to get these wires connected to here without putting solder down into the holes at the bottom. Right. So I think the key thing here is that we've got a positive got to go onto here, so we'll make that a red cable that links between here and here. Well, that's better. How strong they are, I don't know, but I do need to bend them. So there we are, they're fixed and bent. So that's the really tricky part of the operation done. We've already attached, we've taken the spring off here and attached the black cable to it. Now we've got to attach two red cables to there. We said we're going to put black on the other side there, which is easy because it's only one wire to hold, and underneath is the yellow wire. Okay, now here we've got a little 5-volt DC power supply. We'll just connect up the ends approximately to just test it. Just turn it on and check that it works by pressing the button. That's all working. Don't know whether you can see that, can you? But look, when I squash this flat, in other words when I put the whole assembly together, it actually puts the switch on and the unit is on. So I haven't got to do anything special in there with that switch. I could play just a little bit safe and put a little piece of cardboard behind the unit. That way it'll just force it up just a little bit and guarantee that the switch works. Right, now that we've cleared the decks, we can carry on with the assembly. What we've got here is an M4 by 25 long posi pan heads. Now the next thing we're going to try and find is the plate which has got two cutouts in the bottom and no window in it, and that goes on next. The next one has got a window in it and two cutouts in the bottom, and that goes on next. Then we'll put our little teeny weeny piece of packing cardboard in there. Okay, so this is the next one that goes on. It's got a hole on the left hand side opposite the slot that's on the right hand side there. So just pop that on there like that for a second. Okay, so now we're going to take our LED module, and there should be two loose ends, which are the ends that connect to the power supply, and they have got to go through underneath this plate and through that hole, like that. Okay, all will become clear in a second, because now what we've got to do is to put this, first of all I'm going to move that cardboard along so that it's underneath the switch. Then I'm going to tuck this module in there, and you'll see that the cables come out through that hole. Specifically these at the front here, they only need to be on 2 or 3 turns. These little nuts. because what we've got here now are two neodymium magnets. They're 10mm diameter and they're 5mm thick, and they are incredibly powerful. And what we're going to do is to slip those into the square pockets. They should sit just flush with the surface. And then when we tighten these screws up, it should lock the magnets in place. Now, if you remember, we hope that that switch is pressed on. So we better just check this before we go too much further, because we may have to put another 2 or 3 pieces of cardboard in there to make sure that the switch is pushed forward against this front face. And as you can see, when I touch these wires together, we have liftoff. Now the head unit has got its own little problems. Here we've got an M3 grub screw, which is 10mm long, and an M3 nut. We're just going to assemble one onto the other for the moment. And I've got my suitable sized Allen key for the grub screw. And we'll have around about, say, 2 or 3mm sticking out the end here. Now if you look carefully, you'll see that there are 2 of these teddy bear faces, one with big eyes and one with small eyes. You want the one with the big eyes first, and then we'll pop the one with the slot on it on top. And what we're now trying to do is to get the flats of the nut into that little slot there. Should drop in quite easily, and as it drops in, it should locate in the little rectangular slot underneath, and then we're going to put this little rectangular slot here on top, like that. So we've got a 3-piece module now. Now it more or less lines up, but not quite. So what we can do now is to pop our make sure that our head goes through there, and we'll just tighten up the screw just somewhere at the moment, just lightly, and holds the whole assembly. Doesn't hold it together, but it lines everything up. Okay, if you look down here now, you'll see that all the holes are nice and concentric. Okay, so what we now need to do is to get some of our acrylic adhesive, which is called a welding. This happens to be a PETG weld cement. Acrylic cement won't weld PETG. Surprisingly enough, this PETG cement will weld acrylic. It produces a slightly strange effect, but it works perfectly okay. We're not interested in the cosmetics. You can buy this stuff probably off the internet without any problem at all. It's just a small container. But be careful with it, because it will evaporate very quickly, and you don't want to get it on your hands. They do tell you on there, wash your hands quickly if you do. But the simple way to use it is literally with just a stick, clamp this together, and then get a blob of it on the end and just put it on the joint. And as you put it on the joint, so it'll just suck into the joint. And there we go, within a couple of minutes you'll see 1 or 2 bubbles forming in there, and you'll know that it's now probably welded perfectly okay. Now here we've got 3 20mm long M3 countersunk screws. Now it is fairly important that they're countersunk screws, because we're trying to sit up flush against the face of the water jacket. And so these go through there. These holes in the back here have already been countersunk to allow the screws to sit flush or slightly sub-flush. Okay, so we've now got our 3 screws poking through. What we're now going to do is hold them in place with 3 M3 nuts. Make sure they're nice and snug. Now I suspect that every household in the world has probably got half a dozen of these free sample pens or something like it, which probably don't work. Well, we've now found a use for them. we need to take the end off, and we shall finish up with an assortment of springs out of these pens. Now they might not all be perfectly the same, they all be slightly different, because every pen manufacturer has got slightly different design, but it doesn't matter. They're basically all about 4.5mm diameter. We need them to go over our screws like that. Okay, now before we can assemble this up properly, we need to make sure we assemble this the right way round. And the right way round, if we look at the big pockets are to the back. So we need to put the big pockets to the back, and then we need to thread this in here so the clay will sit flush across the back there. Remember, we put a bend on these to start with. Now make sure the cables sit flat across the back there, and we just lock the module in place. And now we'll put the springs in to the pockets and squash the whole lot down like that. Now this one furthest away from you is going to have a special nut, and what I've got a nylock nut. Now nylock nut basically doesn't move. It could be an ordinary nut, but I decided to choose a nylock nut so that we could lock it in place and it stays in place. It doesn't want to move. And then on the front two positions, we could just put nuts on there. I've got my little acrylic spanner here, which is perfectly strong enough to adjust these, but hopefully I've got one better than that this time, because I've manufactured these lovely little thumb wheels out of acrylic. Now if I've got the dimensions right, then hopefully I should be able to press them over a nut. Like that. I made them with round corners in one or two places so that they actually lock into the nut itself, so you push them in. And now what I'm going to do is to get some M3 washers. I'm going to put a couple of M3 washers on there and a couple of M3 washers on that side there as well, just to make sure that the back of this thumb wheel is spaced off. They're going to make it so easy to adjust, because all you've got to do is just touch them with your thumb. And that's beautiful. That is good. So now what we've got is an M4 screw. I'm going to put a washer on this side and a wing nut on this side. And in fact, I think what I probably ought to do is to tighten this up, because I think it'll probably, I don't know, but I think it'll slip if I tighten it up. You'll still be able to move it. So if I put quite a bit of tension on it, yeah, look, I can move it around, but it's basically okay. Right, let's go and test. And then we'll drive the head to the front corner. And now we'll use a little piece of masking tape, and we'll tuck that there and put a burn mark, a scorch mark on there. Just there we go. There's a nice scorch mark on there now. And I'm now going to turn the laser off. I'm going to put a piece of masking tape across the switch. So I've put that tape there to make sure, because I'm a forgetful old sod, that I haven't got anything in front of the laser beam before I switch it back on. So here we are, we've got our beam on. So we've lined that up now so that it's sitting back flush with, on the front of, and approximately on the centre of the water jacket. I think I need to adjust these knobs out back to a nominal position to start with, and then what we need to do is to adjust the, there we go. So we've now basically twisted the magnet on its base so that the beam has gone into the first mirror, into the second mirror, and in fact I can see it. So there we are, it is on mirror number 3. Now what I'm going to do is just twiddle with the knobs just a little bit. And what we're trying to do is to set the beam up to a nominal position, provided we don't move the head. In other words, we leave the head in that position there at the front, then this beam doesn't have to line up with the axes. All it is a reference beam which allows us to take one mirror off at a time and come back to that same position. So we could remove all the mirrors one at a time and reset them back to that position. It's a reference position, not a setting condition. As I have found out, this system is not really suitable for completely setting up the machine. You still have to go about it with the pulse test, which I'm not in favour of, but hey, I've got to live with it. But at least I've minimised it now with the line of sight technique that I developed. Maybe a little bit more tedious to make than the Mark III, but suits people a lot better, I would have thought. And of course, at the end of the day, if you like the design, then you can adapt it whatever way you want. It's the principles more than anything else that are important. So anyway, good luck. If you want the DXF files and all the information to make it, the same applies to this Mark IV as applies to the Mark III. Just send me your email address, message me with your email address and a request, and I will send the information to you.